Hello, 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 hello. This is Bakwa Phosphate Academy, Bakwa Phosphate Academy of Science and Technology. Today we will be looking at chemical kinetics, that's rate of reactions. And you can contact us through +237 67995 3185 for our online classes. You know that we are able to teach you online directly at home if you have your internet services and an Android phone. Say an Android phone like what I'm having here. And you can also write us using bakwaphosphate@gmail.com. Don't forget to subscribe and hit the subscribe button. Today's video is very interesting because we'll be looking at chemical kinetics. But before we get to the lesson, I want to thank all of you who are there. It's because you are there that I am able to produce these live videos on lessons in chemistry. And especially I want to thank my colleagues who are there, and even most of you who are able to write me personally telling me different method to use to teach. I want to say may the Lord bless you. I am a student, and Bakwa Phosphate is still learning, and I would like to get those critiques and corrections, especially from my colleagues that are more professional than I am in the field. Thank you so much. I will be waiting to hear more critics from you, especially my colleagues, on how we can help our students to be able to sit at home and study, especially to do their assignment. That's all about Bakwa Phosphate Academy of Science and Technology. We want them to be able to use science and technology, use the social media as a platform to study. As we already know, the YouTube is already one of the best universities in the whole world. Everything you want, you can get it from YouTube. I'm here today with chemical kinetics, and we will be going to look at the definition of chemical kinetics, rate of reactions as we always call it, and we will also look at the unit of chemical kinetics. We will look at the importance, why should we study the rate of chemical reactions, and we will look at some factors affecting the that will be able to alter the rate of chemical reactions. This video is good for even intermediate secondary and or ordinary level and advanced level student. For the advanced level student, just a base for you. Don't forget to get to the lesson for advanced level where we're looking at integrated rate laws for zero order reactions, first order reactions, and second order reactions and their characteristics. Thank you so much. We are getting directly into the videos. Permit me to go to put my picture at a certain level here. You can equally, that is where I would like that the video should be. Just permit me reduce it this way. Thank you. I hope that you can be able to see my contact there. Thank you so much. We're getting directly into the videos of today, and permit me to go to the video. We are looking at chemical kinetics, rate of reaction. And someone may be thinking, what is chemical kinetics? What is rate of reaction? I'm giving you the definition directly. What we call chemical kinetics, rate of chemical reaction, is simply the rate of reaction is the decrease in the concentration of the reactant per unit time, or an increase in the concentration of the product per unit time. During the chemical reaction, we will observe that during the chemical reaction, we will have reactants. Yes, let me write. Let us look at a reaction. Permit me to take my pen and to change the thank you. Permit me to go directly to an example of an equation. Like, for example, if I have A reacting with B to form, say, C plus D. Yes, to form C plus D. Now, during the reaction, we will observe that the concentration of A and B will be decreasing. The concentration of A and B will be decreasing. The concentration of A and B will be decreasing, while the concentration of C and D will be increasing. Now, so what do we call rate of reaction? We say that rate of reaction, R, is simply going to be the rate at which the concentration of A decreases, or the decrease in the concentration of A with time. Or we can equally say that rate is the same like the increase in the concentration of, permit me to say this is D, and the C as time is passing. So as time is passing, we observe that during this reaction, A and B, the molecules of A and B will collide and to form C and D. And A and B initially, when the time is 0, at time T equals to 0, we have only the concentration of A and the concentration of B. We do not have the concentration of C and D. But as time, at a certain time T equals to T, we observe that the concentration of C will be increasing from 0, and the concentration of D2 will be increasing. You see that. But the concentration of A and B, will be decreasing. So the rate of a reaction will simply be the decrease in the concentration of A with time, or the increase in the concentration of C and D with time. I can again say it can be defined as the rate of the decrease in the concentration of B with time, or the increase in the concentration of D with time. So the rate of the reaction will be defined with respect to a particular reactant, or with respect to a particular product. We want to look at the unit of the rate of reaction. What is the unit of the rate of reaction? The unit of the rate of reaction will be dependent on the parameter that we are measuring. What parameter are we measuring? For example, if I am measuring pressure, then I know that the rate of the reaction will be measured in atmosphere or millimeter of mercury or Pascal per unit time. Per unit time. It is then that we can talk about millimeter of mercury per minute or per second, or you can, the unit of time could be per minute, per second, per year, per day, per week. But if in a reaction I'm measuring, say, concentration, change in concentration, if I'm measuring change in concentration, I know that concentration is measured in mole per dm cube. That's what I call molar concentration. Or there are other units of concentration, like we know gram. We have unit of concentration as gram per cm cube, or gram per dm cube. So the rate of reaction can be, for concentration, when we are measuring the parameter here that is changing its concentration, we can have mole per dm cube per second. Mole per dm cube per second. What about volume? If we are looking at, probably a gas was, was produced during the reaction, and we are measuring the volume of the gas, probably using the graduated gas syringe method to measure the volume of a gas that is produced. You know that the volume of a gas will be measured in cm cube, and the volume that is measured per second, that will also be the unit of the rate of reaction. That will be the unit of the rate of reaction. Today we want to look at importance of studying rate of reaction. Why is it important that chemists should study rate of reaction? Number one, it helps the industrial chemist to obtain a good yield. Studying the rate of a chemical reaction will help the industrial chemist to obtain a good yield of product in the shortest possible time. Meaning that an industrial chemist will go to the, laboratory or an industry and will try to study the rate of chemical reactions, and the purpose is that it wants to get a good yield. You can repeat with me. It wants to obtain a good yield. Good yield. Yeah, good yield of product. Every day chemists are looking for all the possibility to use product and produce more product. Good yield of product in the shortest possible time. Number two, how is studying the rate of a chemical reaction important to chemists? It will also help an industrial chemist. Who is an industrial chemist? An industrial chemist is a chemist that is working in the industry. It is going to help the industrial chemist to know the reactant whose change in concentration, reactant whose change in concentration will improve the yield, will improve the yield of the product. There could be so many reactants during a chemical reaction. For example, the reaction of A above and the B to produce C and D. We have two reactants here, and we see that A and B. Industrial chemists will be interested to check, if I alter the concentration of A, what will happen to the production of C and D? If I alter the concentration of B, what will happen to the the product C and D? So in an industrial chemist, we'll know exactly which reactant, if we alter their concentration, will give us more yield of a particular product that we are interested in having. Number three, it helps the chemist to investigate the mechanism of a reaction. Especially this is very important for the advanced level student. The mechanism of a particular reaction is determined by the rate of that reaction. You can also check my videos on that. I've had a video on how we can determine the mechanism of a reaction using the rate of chemical reactions. Number four. So we talk. Number three is mechanism. Number four. Why is the rate of a reaction also important to us? It helps us to know how fast a reaction will take place. How fast a reaction will take place. Yes. There are many reactions that will take years. For example, if you take for an example, the rate at which excuse me, the rate at which a tree is growing, It takes years for a tree to grow. Now you can also see with me that the rate at which the precipitate of silver chloride will be formed when you add silver nitrate to any solution containing chloride ion, say the solution of sodium chloride or potassium chloride, is instantaneous. The silver chloride precipitate form instantaneous. So the study of the rate of reaction will be very important to us to know how fast a reaction will take place. And number 5, help the chemist in choosing and using of a catalyst. Choosing and using of a catalyst. Choosing and using of a catalyst. What is a catalyst? A catalyst is a substance that will help to increase the rate of the chemical reaction. Yes, it will help to increase the rate of a chemical reaction. Otherwise, it will be called an inhibitor, which is a substance that will instead decrease the rate of a chemical reaction. So a catalyst will increase the rate of a chemical reaction. During the reaction of ammonia, formation of ammonia, we saw that finely divided ion was used as a catalyst. Yes, an industrial chemist will know which catalyst will have to change the rate of this chemical reaction by increasing it. Which catalyst? So the choosing of a catalyst is very important to us industrial chemists, and we choose catalysts depending on our knowledge of the rate of that particular reaction. We want to move ahead now. We want to look at the collision theory. The collision theory, we want to say that in the collision theory, the first statement, the first point to note here is that reacting particles must collide. Yes, reacting particles must collide. That is the first thing. Before any reaction takes place, reacting particles must collide. If reacting particles they don't collide, then reaction will not take place. If reacting particles don't collide, reaction will not take place. Number 2, to note, this is point number 1. Number 2, for a reaction to take place, the reacting particles must collide with an energy which is equals to EA, which this EA is called the activation energy. The activation energy. This EA is called the activation energy. Remember, in thermochemistry, you see that we are able to know the feasibility of a chemical reaction. In thermochemistry, we know whether or not a chemical reaction will take place. You see, that's why we talk about reactions that are feasible. We say they are exothermic reaction. Exothermic reaction. And we explain that in exothermic reaction, the enthalpy change, delta H of the product minus delta H of the reactant, which will give us delta H of the reaction, is equals to negative. Is equals to negative. If you permit me to put up the energy level diagram here for an, for an exothermic reaction. Consider this is delta H of reactant and this is delta H of product. You see that delta H of this delta H of product and this delta H of reactant. You see that delta H of product is lower in energy. Permit me to put down that diagram here. Now, here we are. This is enthalpy. or energy in joules or kilojoules. This is reaction coordinate. This is the reaction coordinate. Here we have the difference in the energy between the product. This is delta H of product and delta H of reactant. You see, delta H of this reaction is delta H of product minus delta H of reactant, and of course we see that is going to give us a negative value. This kind of reaction is feasible in chemistry. This reaction is called exothermic reaction. Now, the energy barrier here is what we call EA. The energy barrier here is EA. For reaction to take place, point number 2, the reacting particles must collide with an energy which is equal to or more than the activation energy, which we call it EA. So if reactants here, say A and the B particles, they collide and they don't have sufficient energy to be able to have energy which is equal to or more than the activation energy, the reaction will not take place. This will lead to what we call the intermediate complex. A complex will be formed here at the peak of this energy diagram, at a peak here that can fall back to reactants or fall back to product. You can check my next video specifically on activated complex and the formation of product. Now we want to say that the second point of the collision theory, it simply says the reacting particles must collide with an energy which is equal to or more than the activation energy for a reaction to take place. If they don't collide with this energy, the reaction will not take place. What is activation energy? Activation energy is the minimum is the minimum amount of energy required to start a chemical reaction. The minimum amount of energy required to start a chemical reaction is called the activation energy. According to the collision theory, if particles collide with energy which is not equal to the activation energy, then reaction is not going to take place. Reaction will not take place. Now, we want to move forward to the next point that the collision theory take note of. The collision theory take note that if reaction must take place, reacting particles must collide with good orientation. Their orientation must be good. Must be those orientation that will produce reaction, will produce product. Yes, that's all we want to know about the collision theory. The particle must collide. And when they collide, there are two kinds of collisions. We have noted that we have what we call effective collision and non-effective collision. Effective collisions are those collisions that will particles collide with energy which is equal to or more than the EA, and non-effective collision as a collision that particles collide with energy which is not up to or equal to the activation energy. That is that for the collision theory for today. And the next thing we want to look at factors affecting the rate of chemical reactions. Number 1, we have concentration. Number 2, we have surface area of reactant. Number 3, we have temperature. Number 4, we have light. Number 5, we have pressure. These are all factors that will affect the rate of chemical reactions. Number 6, we have catalysts. Yes, briefly we are going to look at how these factors will affect the rate of chemical reactions. Permit me to adjust my writing part. How these factors will affect the rate of chemical reactions. We have concentration, surface area of reactant, temperature, light, pressure, and catalyst. It will be important that we use an equation in each case to be able to see how these factors will be able to affect chemical reactions. And this video we are going to see in the next video. Just click the subscribe button, click the like button, and then you'll go to the next video, which is titled Factors Affecting Rate of Chemical Reactions. In that video, we will take each factor one after the other with an example of an equation, and we are going to discuss how the factor will affect the rate of a chemical reaction. Thank you, and bye-bye for today's video. Bye-bye for today's video. We are saying that we are going to meet you in the next lesson. Just click before the subscribe button. Don't forget to subscribe to our channel. Don't forget to subscribe. This is Mbakwa Phosphate Academy of Science and Technology. We are back here and we say that today we're looking at chemical kinetics, and we were looking at the definition of chemical kinetics, the different units we will meet in chemical kinetics, that's rate of chemical reactions. We look at the collision theory, and we equally look at factors affecting the rate of chemical reactions. But I did mention that the factors affecting the rate of chemical reactions are discussed in detail in the next video. So just hit the subscribe button and the next video will be coming up to you. Thank you. Don't forget to share with us how you feel about our video. Have a wonderful weekend.